Welcome everybody to this, our third lecture in the From the Rooftops lecture series from the Landscape Architecture Department here at the Weitzman School of Design at the University of Pennsylvania. Each week I introduce a different member of the faculty who does the lecture for you, and this week I'm doing the lecture. So I'm briefly going to introduce myself. I am the Meyerson Chair of Urbanism and the Professor and Chair of Landscape Architecture, as well as the Co-Director of the McHarg Centre here at the Weitzman School of Design. Prior to joining the school in 2013, I was the Co-Director of a landscape architecture and urban design company, Room 413. This design firm, run with my partner Vladimir Sitter in Australia, was documented in a Penn press monograph in 2005. I was also the former director of something called the Australian Urban Design Research Centre. I've been practicing and working as an academic simultaneously for well over 30 years now, and as a consultant I have specialised in the formative stages of projects ranging from little things like gardens, plazas, memorials, museums, and to bigger things like suburbs and waterfronts. My research projects have involved scenario planning for cities, for megaregions, and even for nations in some cases. And my creative work has been exhibited in galleries such as the Guggenheim in New York, the Venice Biennale, the Museum of Contemporary Art in Sydney, the Gardner Museum in Boston, the Maxi Gallery in Rome, and the Canadian Design Museum in Toronto. I've published 6 books and well over 100 single-authored academic papers on the theory and practice of landscape architecture, and I am also the creative director of the Interdisciplinary Journal of Landscape Architecture, LA+, which is also produced here in the faculty at the Weitzman School, in the Department of Landscape Architecture, here in the Weitzman School of Design. My most recent research, some of which I will talk about or touch on in today's lecture, concerns global flashpoints between biodiversity and urban growth. This research has been documented in a recent publication, a web-based platform titled the Hotspot Cities Project, and the Atlas for the End of the World, Atlas for the Beginning of the Anthropocene. The Atlas analyses how nations are performing with regard to reaching 2020 UN targets for protecting biodiversity, and it identifies the conflict zones between urban growth and endangered species in over 400 cities. This work has been published and reviewed widely by organisations like Scientific American, National Geographic, among many others. So, welcome to today's lecture, and I will begin. Welcome everybody. My name is Richard Weller, and this is the next installment of the From the Rooftops Landscape Architecture lecture series at the Weitzman School of Design at the University of Pennsylvania. I'm going to talk today about the research that I've been doing here at Penn over the last 5 years or so with students. I'll initially position that research within the context of the Anthropocene, and then I'll articulate the research questions and why I think they're important. I will show you the method that we've used to explore these research questions, and we will consider some of the findings from the research. We'll also look briefly at a couple of other projects that are related to the kind of work I'm currently interested in. And so let me begin with the Anthropocene. This is Paul Crutzen, a celebrity scientist, most famous for launching the term the Anthropocene, I suppose. He stood up at a conference at the turn of the century and said, I think we really should stop talking about the Holocene. The Holocene is a period of nice weather since the last ice age. It's the period during which the agricultural revolution, the creation of cities, and sort of what we call civilization has emerged to become a planetary scaled force of nature. Now, the net consequence of that flourishing that occurred during the Holocene is, of course, climate change. Climate change is nothing for the Earth system itself. That's just the Earth making some minor adjustments to distribute heat and energy and its chemical compositions and so on. the Earth is always working on a kind of a balancing act of all of the forces that make the constituent elements of the Earth system itself. It's just what the Earth does. But climate change, of course, is horrendous for us in the sense that it radically destabilises the weather. So culturally, it's a dramatic moment, if not an apocalyptic moment, in what is hitherto a fairly the brief appearance of mass populations of human beings with tremendous power, drawn most notably from our ability to harvest fossil fuels. And so Crutzen cites the origin of the Anthropocene with the Industrial Revolution from about the turn of the 18th to 19th century. He says then there is a second phase to this early history of the Anthropocene, and that is what's known as the Great Acceleration, the period post-World War II, where there is, certainly within the developed world, a radical increase in the creation of cultures of conspicuous consumption. And as all of the economic registers go up steeply, so too do the environmental consequences of our actions. And if anything, the Anthropocene is an age where we realise the consequences of our actions. Climate change itself is the net accumulation of the consequences of our actions. So the project of modernity to build a utopia was mistaken in the sense that it didn't account for the ecological consequences of our actions. Into the future, we will have to take account of the ramifications of our actions. We can no longer get away with unintended consequences. And I think what that means is certainly taking responsibility for our actions. That's one thing. Or as Bruno Latour says, love your monsters. Take responsibility for the Frankenstein that we've created. But more than that, from a design perspective, I think it's the dawning of an age of design, right? Where everything has to be designed. Because that is to design something means to act intentionally, insofar as we can, and then take responsibility for that intentionality. That's designing the future, that's designing objects, that's designing ultimately things like planets. And even though that will strike many of you as hubris, that's the scale of thinking that the Anthropocene invites, I think, and necessitates. And it also is a scale that is not foreign to landscape architecture, and I think we can shuffle scales between very small projects. They're terribly important. Every molecule is important, but the very small and the very big, and we try to bridge those scales in our work. Now, the third phase that relates to this that is what Crutzen says the third phase of the Anthropocene, he says, is the phase we should move into now. And listen to this, he refers to it as a phase of planetary stewardship. Now, that's something Ian McHarg said 50 years ago. That's the central message of McHarg's book, Design with Nature, published in 1969. So Crutzen is really handing landscape architects their mandate here and reconfirming some 50 years later what McHarg had already set out for us as our professional responsibility and the scope of work that we should be engaging with. And so over the last 5 years here at Penn, that has worried me and motivated my work with students, and you'll see that momentarily. To make the point, here on the left you see McHarg's original tome, Design with Nature, and we just celebrated the 50th anniversary of the book, of the publication, arguably the most important work of landscape architecture in the 20th century. And to make the Design with Nature Now book as a homage to McHarg's original work, we gathered around 25 projects from around the world that we think certainly complicate the idea of designing with nature, but also suggest ways forward and provide lessons for us as we move deeper into the 21st century, which, as I said in the introduction, I think will be a century of design, where we take responsibility for designing systems, designing buildings, designing cities, designing ecosystems, and ultimately designing the planet. And that's no small task. It's not hubris. It's actually profoundly humbling. The question is, how do you steward a world that might look like this? And by that I mean, in this image of the world, what we've done with this map is we've melted the ice caps. And that means the ocean, the sea level would rise up to about 72 meters. And on the map you can see all of the names of cities which would be effectively drowned. So the world as we know it, the trading networks, the culture of all of our settlement patterns would be radically, destroyed, effectively destroyed. So that in itself, should that happen, and most of the evidence is pointing to this happening, that the ice caps will melt and the sea level will rise. Again, not an unusual phenomenon for the planet itself, but certainly this is going to be radically challenging for civilization as we know it. There are some other challenging circumstances, and this relates to land use. So there's sea level rise on the one hand, and of course all of this is connected to the problem of excess carbon in the atmosphere that I'll come back to. But there's also, in terms of land use, we're going to face huge challenges. And just to make it really clear for you, as we push towards a global population of 10 billion people sometime this century, which seems to be almost inevitable, and let's assume those 10 billion people live like Americans. That just means eat like Americans. Go shopping to buy whatever food you want, kind of when you want. People that shop in supermarkets. The food systems of the world have become detached from the seasons, and we have landscapes of monocultures to produce the crops for the beef industry and so on. Now that's assuming this system can actually, it's not a particularly resilient system. It might not endure the 21st century, but let's assume it does. If you had 10 billion people living and the way, just on the average diet of the average American, you would need 93% of the Earth's terrestrial surface, right? I just want to say that again. 93% of the Earth's terrestrial surface to feed 10 billion people the way in which Americans currently take for granted. That's a lot of land. Now remember that 3% of the Earth's terrestrial surface is currently urban and suburban, so you can take that out, and then you've left with 4%, which is the alpine areas, pretty much, landscapes where we can call that a sort of global zoo, and typically biodiversity does get sort of corralled into these landscapes where humans have no other use for them. Now, on the other hand, if you think also, that percentage that I've, in terms of food production, is extreme, particularly when you think that 33% of the Earth's terrestrial surface is in fact desert. So that means that if you're going to find the land area for food production at our current agricultural yields, you basically need to green the deserts. So that's going to completely change the ecology and the climate of the planet even further, with massive energy involved in terms of harnessing, probably desalinating water from the oceans and so on to just grow enough food for the population of 10 billion people. Now, if you also factor in now another land use that could be increasingly prominent as the 21st century unfolds, that is forestry for decarbonisation, then to sort of strip the carbon out of the atmosphere for, again, 10 billion people living with the carbon footprint of Americans, to sequester the carbon emissions of 10 billion people living like Americans, you'd need 88% of the Earth's terrestrial surface. So there's a fundamental conflict here between food production, carbon sequestration, and the actual extant conditions of the Earth's terrestrial surface, 33% of which is desert. So something's got to give, right? I mean, what this means is that every square foot of the Earth's terrestrial surface will need to be optimized, shall we say, or designed, planned and designed. There's no more excess space. We have used, and we will continue to use, even more aggressively, use the planet for, the landscape of the planet for, various purposes, and those purposes are competing in many cases. What they're competing with, of course, is a completely different kind of worldview that comes from a conservation agenda, and this is E.O. Wilson's most recent idea and polemic. His latest book argues that we should give back, the book is called Half Earth, and give back half of the Earth to biodiversity. So, his argument is that we should relinquish 50% of the planet which can be then recolonised by biodiversity. I mean, it doesn't really say where that land should be and how this would be administered and so on, but it's interesting that we live in a time where a biologist can put forward the proposition that we should relinquish half of the land area of the entire planet. And that, of course, is at odds with the demands on landscape for food production or carbon sequestration and so on and so forth. Now, with regard to what's happening, I think I just want to briefly refer to how this has been encountered in the sciences and in the arts. In the case of the scientists, I think the general project is to try and understand the Earth system and how it works with greater precision and accuracy. And that means developing holistic models of how the Earth system actually functions, because if we have those holistic models, we can better predict the consequences of our actions within that meta system. And I think this is really fascinating, that you see the book cover on the right, Global Change in the Earth System, which was published in 2004 as the result of the International Geosphere-Biosphere Program that ran from 86 through to 2015. And the description of the book itself is, I'll read the quote out to you. The purpose of the book, the purpose of the exercise, was to describe and understand the interactive physical, chemical and biological processes that regulate the total Earth system, the unique environment it provides for life, the changes that are occurring in that system, and the manner in which these changes are influenced by human actions, right? So culture here is being written into nature. This is not just a study of nature as a thing unto itself. This is a study of the consequences of humans interacting with the Earth system itself, now that they have the capacity to change the Earth system at a holistic level. Now, the purpose of the book is, you can see the list of authors there. There's a group of scientists, the main authors, but it's actually authored by thousands of scientists, all putting their models together to try and build one total synthesized model of the Earth system. So it's extraordinary that we live in a time when we're able to change the Earth system, but we do understand its basic machinations. We understand how the system works, but not with any incredible precision, whereby we can, and in some ways we don't understand the actual complexity of the system, and yet we're prepared to change that system. And now changing that system is proving perilous to our own survival. So the stakes are really high. So in other words, the scientific community is getting on with modelling, as it should, and that will give us the predictive power that models always have to a certain degree. Now, at the same time, if we swing across to the arts and the humanities, I think you can see a veritable panic going on. Just look at the covers of these books. These books are all from the last few years, and they're all apocalyptic in tone and rather melodramatic and epic, let's say. And so I think that's also a very clear indicator of what's happening as the realization of climate change dawns upon us. It means that it calls into question the human being and our identity at a very fundamental level. It calls into question our economics. It calls into question our theologies. It calls into question so much that we have built our culture upon. And so, in the arts and the humanities, people are not so much asking how the Earth system works. They're asking, what does the Earth system mean in relation to human identity? And so these two projects, the scientific and the artistic, perhaps the greatest power will come from the coupling of those two modes of inquiry. if we can just to simplify it and set it out across a scale or a spectrum, I've done that with the graphic at the bottom of all of the book covers. And I would say that the current discourse of resilience and design, what's going on in design culture, if I can try and translate this into design culture, and politics too, of course, design and politics are always twinned. You tend to have one extreme is that, or one, you can chart the course between adaptation and, on the one hand, and mitigation on the other. And they're two really important words. Adaptation means that, organisms and systems adapt. They change to suit the changes that are occurring around them. Mitigation is a bit more radical. Adaptation, you just adapt to the circumstances and try to get on with life. Mitigation means that you go to the root cause of the change and change it. You mitigate the actual. Adaptation means it's like getting symptoms when you're sick. Your body is adapting to the virus. Whereas mitigation means that you would go straight for a cure for the virus itself. Now, the problem here is, of course, that in the situation of climate change, whereby you have a species such as us that are addicted to fossil fuels, and fossil fuels are the problem. In a sense, we are the virus, and so political culture is being fought across this spectrum of adaptation being necessary on the one hand, but somewhat conservative perhaps, whereas mitigation would see the complete upheaval of society as we know it by taking fossil fuels out of the equation, which would radically reshape how we organise contemporary culture. So design, you as designers, all of us as designers and practitioners and theorists of design doing work have to position ourselves somewhere philosophically along this spectrum from adaptation to mitigation. This is being played out on a planetary scale through the aegis of the United Nations, of course, and I'm not going to talk about all. This is the global goals for sustainable development, and I'm not going to talk about all of them, of course, but I'm going to zero in on one that concerns landscape architecture specifically, and that is number 15, Life on the Land. And it's within this that we've couched our research over the last few years here at Penn. In particular, we've positioned our research in relation to the what are known as the Aichi biodiversity targets. These are targets that have been developed and are administered through the Convention on Biological Diversity, itself an arm of the United Nations. And within there's a handful of targets. We've focused in particular on Target 11. And Target 11 essentially says that, well, I'll read it to you. By 2020, so we've got, it's almost over. This has been a decade of work that, by 2020, at least 17% of terrestrial and inland water areas and 10% of coastal and marine areas, especially areas of particular importance for biodiversity and ecosystem services, are conserved through effectively and equitably managed, ecologically representative and well-connected systems of protected areas and other effective area-based conservation measures and integrated into the wider landscape and seascape. Now to me, that's a design brief for landscape architecture. And so we focused on this and decided that we would build our research around the target of 17% terrestrial area protected by the end of 2020. And you'll see that we focused on these words in particular that I've underscored with the red line there. That the land that is protected and set aside as conservation should be representative and it should be well connected. And what does that mean? Representative means that you can't just now go into Siberia and lock up a big area of land and say, okay, we're done, there you go. That's 17% of the Earth's terrestrial surface. We've met the target, we can all go home. Because that's not representative, that's just representative of Siberia. So to be representative means that you really need to have 17% protected in each of the world's ecoregions. And there's over 860 ecoregions, right? So as you'll see, what we've been doing is looking at particular parts of the globe to make an assessment of whether, in fact, at the eco-regional scale, nations are meeting that target of setting aside 17% of their land area so that it represents the true ecological diversity of their sovereign territory. Now, connected is even more interesting and complicated because well-connected means that the fragments of area of land that are protected, the lands that we put a fence around and call reserved for conservation, they should ideally be connected with one another. So that at a planetary, that calls into question land use at a planetary scale, as you will see momentarily. On this image of the planet, what we've done is taken out all of the land that is not currently protected. So what you see there is 15.4% of the Earth's terrestrial area which is currently under some form of recognised protection. That is recognised by the IUCN, the International Union for the Conservation of Nature. You can just make out the outline of the continent of Africa there in the bottom left, okay? And what does the image tells you? It shows you that it's an archipelago. Nothing is connected. And is it representative? Maybe, but not really. It doesn't really, all of those blobs of conservation, these islands of conservation, they don't pick up each of the ecoregions. These are distributed according to ad hoc conservation battles over the last 50 or 60 years, as much to do with economics and politics and culture as anything. It's not a rational representation, an exact representation of the collective mass of biodiversity on the planet. So we wanted to measure the degree to which it is not representative, and we wanted to measure the degree to which these areas are not connected. And then we asked, well, here's the research question. Are the world's protected landscapes ecologically representative and well connected? And if not, then how can this be improved? Now, the target for the end of 2020 is 17% of the Earth's terrestrial area. And I said to you, we're currently at 15.4%. So there's only 1.6% of the Earth's terrestrial area to secure by 2020 to meet the target. So that would be a huge achievement, right? And it is noteworthy that the conservation movement and the NGOs, and it is an incredible achievement to have even secured 15.4% of the Earth's terrestrial area. Is amazing. And it's an unlikely story, as it's happened over the last, since the 1960s, really, since the conservation movement in its modern carnation was inaugurated. Now, that 1.6% you think is not much, but it's actually close to 700,000 central parks. Right? So there you are, the icon of landscape architecture, the great work of landscape architecture from Olmsted in the 19th century. Now we're saying in the 21st century, perhaps the great work is to ask the question and implement the location of 700,000 central parks to meet a United Nations policy setting under the aegis of the Convention on Biological Diversity. Now, if you put these parks end to end, they would run around the planet 70 times, as you can see in the image on the right. Now, with regard to connectivity, there's your Ariadne's thread. There's your great connectivity, right? You could use that. If you could weave those central parks on a planetary scale, you could do a very good job of stitching together all of the currently isolated fragments of the world's global conservation estate. You could also locate these 700,000 central parks in areas of land where there is none or a very small amount of representation through current protected lands. So the research question we were asking then is, where should those 700,000 central parks be as a matter of priority? And, it's too much to look at the whole, well, we could have looked at the whole world. I mean, it's just GIS mapping, it's not that hard. But we decided to focus on the world's biological hotspots as a matter of priority. Now, why did we do that? Well, because these are the biologically richest and most threatened places on Earth. So if you really wanted to do the most important thing you could do for conservation and biodiversity now, you would try and do it in these regions as a matter of priority. And so we've studied each of the 36 biological hotspots, all the regions that you see marked in browny red colour on this map. And we just conducted an audit to see how they're performing with regard to meeting the 17% target. Our conclusion is, well, as you can see from the map, the areas that are green are the areas that have met the target. This map is drawn at an eco-regional scale, so it's quite precise, and it shows you precisely the areas which have secured 17% or more of their landscape as conservation. All of the brownish areas have not met the 17% target and in many cases are performing well under that target. 21 out of the 36 hotspots do not meet the target, and within the hotspots, out of the 391 ecoregions that constitute the hotspots, 221 do not meet the target. I'll just show you the sort of mapping that we've done by zooming you into one of the hotspots, the Atlantic forests on the coast of Brazil, primarily. Hotspots don't conform to national territory. They are based on biological boundaries, which I think also makes them such a compelling thing as an emerging form of governance, perhaps, for a new society that valued the ecosystem. What you can see here is the Atlantic forests as a whole are performing very badly. So the box graphic on the right-hand side shows you that this hotspot and the nations that are responsible for it, Brazil, Paraguay, have only reached 8%, whereas they should be at 17%. So they're not even halfway there. So they've got a lot of work to do in the next few months before this phase of trying to meet the targets by 2020, the deadline is imminent, shall we say. We then, from the hotspot, we break it down into the ecoregions to just look at it in a slightly finer grain. So here are each of the ecoregions, and we hold the 17% target up to each ecoregion, and we find out the shortfall, and we also then compare the shortfall to the amount of habitat that is just left. It's not protected, but there might still be habitat in these landscapes, and we can quite clearly calculate, well, this is how much land area you need to meet the target in this particular ecoregion, and this is how much habitat you've actually got left standing there that you could meet it with. So that's quite an interesting data set, because it suggests that investment in certain lands should be prioritised. And it was also, this work is quite controversial too, because it embarrasses governments. People don't like maps, and they don't like maps that show accurately how nations are performing vis-a-vis meeting targets that they are officially signatory to. As we go through all the ecoregions, and we do this for all of the world's 36 hotspots, so it's a huge amount of mapping work that's been done. Now, we do that in terms of the broader landscape, but the socio-political, economic, and the ecological dynamic of much of what is happening with the world's landscapes is driven by cities. So there's a second phase of the research where we've looked at the behaviour of cities, and by cities I mean communities of 300,000 people or more. That's how the UN defines a city. And so we've looked at all of the 423 cities in the world's biological hotspots, and where you see a yellow dot on this map means that the city is sprawling directly into remnant habitat. Okay, so 383, over 90% of the cities that's communities of over 300,000 people in the world's biological hotspots, are currently sprawling directly into remnant habitat harbouring endangered species. So the mapping we've done is we've worked with Karen Sito's data set that forecasts the growth of cities. We initially did it out to 2030. We've been able to do it now out to 2050 because her data set's been updated. And then over that, we map that onto habitat, remnant habitat, and we map that then onto the ranges of endangered species, and we can illuminate through that the conflict zones between forecasted future urban growth and endangered species, so the conflict between urbanisation and biodiversity. Now, when you look at the image of the world and you say to yourself, wow, each of those cities is destructively growing into the world's most precious habitat. That's a frightening map. It's a calamity on a planetary scale, and it largely goes under the radar of the international planning and design community. To make this calamity more manageable as a subject of research, we reduced the sample set of cities down to 33, and you can see those marked in red dots on this map. Those red dots mark what we call the hotspot city capitals. They're the biggest and fastest growing of the cities in the hotspots. You know, the cities that are capable of the most cultural and economic clout, have political clout, but they're also the most destructive in just the basic sense that they're the biggest and they're expanding rapidly. Their footprints are sprawling directly into remnant habitat. So that's become the sample set of cities that we've worked with over the last few years specifically, and we've invited representatives of these cities to the university to discuss the shared problem of how do we avoid sprawling into remnant habitat. Our argument has always been that sprawl is not a fait accompli. Cities don't just have to grow blithely into precious landscapes and destroy those landscapes. The city is a cultural phenomenon. It can be planned and designed, and its forces can be redirected. Here's the more detailed mapping of each of those 33 cities. These are actually really high res and detailed maps. It just doesn't come through when you put them all at this scale in a PowerPoint presentation, but I'll zoom into one or two of them and you'll get a feel for it. It's interesting also to when we talk about urbanisation and sprawl, the zone around, our argument has been, or my interest is currently, what we call the peri-urban edge of cities. And in the image on the left, that's from Perth in Western Australia, you see the peri-urban sprawl of a city that is planned through a central planning agency, and it's a planned economy. And whereas in the image on the right, in Medellin in Colombia, you see sprawl on the peri-urban occurring as a self-organised, self-constructed, or what we call the informal city. The formal city on the left, the informal city on the right. So if you want to address the conflict between peri-urban sprawl or urban growth and biodiversity, you need to think about these two different forms of urbanisation, the planned and the unplanned. So the phase of the research that we've moved into most recently, in the last year or two, is a series of case studies where we're looking at particular cities in particular hotspots that have particular cultural conditions. And I'll just show you some examples of where that's taken us so far. In the case of the first case study is Bogota in Colombia. The second case study we've looked at is Sydney, Australia, and most recently Los Angeles, California. This is Bogota in Colombia. It's a city of currently 9 million people, and all of the red that you can see around the outside of the city there indicates land where there is a conflict between biodiversity and forecasted urban population growth out to 2050. So if we do nothing, the city will just sprawl into those red zones. It'll just get bigger and bigger, and you'll lose more and more habitat. This is an animation of our study of Bogota, and Bogota is a very complicated situation. The existing city is the grey area down on the right of the plan. That's 9 million people, and the city is predicted to effectively reach something like 15 million, or almost double. in the next few decades, and it can. So how should that happen? And we've spent a lot of time. What we've tried to do is, well, firstly, we've accepted the urban growth will occur, right? And then we've tried to get in before that urban growth occurs and say, okay, what you should do is secure landscape connectivity. You should secure biological corridors. You should secure riparian zones, the drainage lines, the rivers, the streams, the wetlands, and you should lock them up into a green superstructure by way of preparing for imminent urbanisation. And urbanisation can then take place in the lands in between all of the areas that we've connected here, as you can see in the image. And so we're trying, as a work of landscape urbanism, to integrate urbanism and transport systems with landscape systems. This is a work of synthesis. And it's a long and complex and detailed story that we don't have time for right now, but I hope that the little animation here gives you some sense of how that has been achieved. In the case of Sydney, so with Bogota, we were sort of working with my colleague on this project, David Governor, who is really an expert in the territory. So we had a degree of intimacy with what was going on the ground and what goes on politically and culturally and ecologically and economically in Bogota. But we still did the planning study at a very big scale. It was a whole of city approach, right? The kind of planner's view of the city with making big moves. And that's necessary when you're dealing with large-scale rapid urbanisation. But there are other methods and other ways into the same problem. And in Sydney, we did something different. In Sydney, you can see the same phenomenon here. The red areas are where the city could, is forecast, predicted to grow out to 2050, and where that growth conflicts with remnant habitat and endangered biodiversity. Here we did not take on the whole city and its growth dynamic. Here, the project was set against the background of the appalling bushfires that took place in Sydney last summer, and we've so the project here, the studio that was run with colleagues Jason Cuff, Beth George, Georgia Darling, Chris Kelly, Dieter Hoculi and Craig Burton, was that we would use or explore the idea of using Sydney's urban parks as incubators for the protection and propagation of endangered species. So it's another way of getting at the human non-human relations in the context of urban design. And so we chose Centennial Park, which is a kind of premier piece of parkland right in the centre of Sydney. But it has it's a typically sort of pastoral, picturesque landscape from the 19th century, and it has a lot of land that is sort of doing nothing, as it were. It doesn't have great ecological value. So we decided to try and convert this. It's really parkland for people and horses and dogs and sports, and it's basically human dominance. And we worked on a master plan to turn over that territory to a list of 20 or so particularly endangered species. And the idea was that we would designate patches of territory in this park which would harbour those species. And then into each patch we put something called an animark. And that's a combination of animal and architecture, which is just a research building and a public interface so that the public can go there and learn about these species as they're being incubated and propagated and cultivated in the park. And from there, species could be returned out to the broader landscape of the Australia's eastern forests biological hotspot. So it's an interesting idea to use urban parks as intense sites for animal endangered species incubation, as opposed to building another zoo. This is a more scientific approach, and in many ways a zoo without boundaries. I mean, there is a boundary around the park where the park meets the city, but internally the idea was there'd be no boundaries. And so you're really designing a kind of an ecosystem out of an old pastoral landscape. And here's one project, one of the results from a student, Jinyu Wan. And if you just track with me from the top left through the grid, we'll go from left to right. It's kind of interesting. We asked the students in the very first image up there, after the title page, which is beige, move to the second square on that grid. We asked the students to combine their own body with the body of a particular species. Each student was given a particular species with whom they had to work for the project. In this case, Jinyu was working with an eel that lives within the park, actually, in the lakes within the park. This eel does an extraordinary thing, by the way. Every now and then it wriggles out of the park and literally goes through the stormwater systems of Sydney to get down to the airport and into the ocean. Then it swims 2,000 miles to New Caledonia, where it breeds. The parents die and the offspring swim all the way back to the very same lake in the middle of Centennial Park in Sydney. It's extraordinary. Anyway, this eel was Jinyu's mascot, his client and his partner in the project. And so the first exercise, I asked the students to hybridize or combine their body, their physiological form with that of the animal. So that's what you see there. The second image across from the top where you can see him sort of hunched over in a body of water is, I asked the students to immerse their body in the habitat of the animal in some way. In the third image, I've asked students to see through the animal's eyes and imagine what the world would look like from an animal's perspective. In the fourth image, on the beginning of the second row, I've asked the students to take the basic physical form of the organism and morph it over time, projected into the future with some kind of imagined environmental pressure, right? Like something like climate change or something. How will the animal evolve over the next couple of million years, let's say? So that's another exercise in imagining form and environmental change. In the next three images, the students were asked to make models. And in the models, there has to be an encounter between the human and the animal. And then the rest of the images are working on, diagramming out strategies for the master planning scale of the whole park with the 20 species, the animarks, the small research buildings, the nodes throughout the project. And then in the very bottom row, Jinyu offers some details of his particular animark and the relationship between the human and the animal as curated by the designer. That was the intent of the project. In the case of Los Angeles, we're working on this right now, and we're working in a particular site using what we did in Sydney. We've taken that method but elaborated a little bit, and we're focusing on one particular piece of the red-coloured territory, which, as I have said, signifies the land where the city is forecast to grow into this territory and in conflict with endangered species. And in the case of Los Angeles, we're focusing on this particular piece of land here, Griffith Park, which is famous, of course, for the Hollywood sign, but it's also famous for this animal. This is P22. It's a mountain lion that somehow, kind of miraculously, found its way through Los Angeles, through all the traffic, to get into this isolated fragment of, I guess, protected area. It's really the public park, Griffith Park, and the animal has survived in there. And however, it's a tragedy too, because this male is on his own, so he's not exactly, the species is not going to proliferate in Griffith Park. And you can see here he's wearing the collar because he's tracked and so on. So we went into Griffith Park and we've again worked on a list of endangered species. We've thought about the park as an incubator for these species, and students have had to design micro ecosystems that will incubate the species, but they've also had to design an interface between the human and the animal so that we can get somehow closer to the animal and become more empathetic towards the animal. And I have to say, many of the animals we're working with are not charismatic like this one. I mean, they're incredibly, they're very small, they're irrelevant. If you're just walking, if somebody, to the uneducated, they're not your big charismatic megafauna. And so they've been really challenging to work with. For example, we're working with a slug, very small lizards, things like that the public are largely not aware of. And so how do you design spaces that incubate these animals but also bring humans and those animals closer together into more empathetic relationships and understandings? And so it's fascinating work. I'm going to finish now by, I guess what we've been talking about thus far is representation, right? Representing species, representing ecoregions. I want to close the lecture out by talking briefly about connectivity, and which is, the second major piece of the Convention of Biological Diversity, Aichi targets policy setting. And this is a map that we've produced in the studio, and what's, I think, amazing about, well, all of the graphics that you see there indicate projects of connectivity, and they're on an epic scale. Some are hypothetical and some are actually under construction or have been built. And I think it's an interesting map because it shows you, I guess for the first time since, let's say at least the 16th century or so, the dawn of modernity, during which time we've been largely ransacking landscapes and ecosystems and decimating species. For the first time in that recent history, humans are turning, and they're pivoting, if you like, changing and their attitudes and trying to put ecosystems back together again. Try to build ecosystems, plan and design and enable connectivity. I mean, we've been so good at connecting ourselves with road, rail, telecommunications. We've connected ourselves incredibly on a planetary scale, but we've done it all at the expense of everything else. And so this is almost like a reweaving of land on a planetary scale. It's a historical phenomenon. It's a moment in time. I think it's profoundly optimistic. This is humans acting as stewards. This is humans acting as gardeners. And it's not easy. I mean, we've done such a good job of ransacking everything to sort of put it back together again. And you can't. It'll never be the same. But we can now we can build and construct a new kind of ecology, one that is synthesized with our urban settlement patterns and our systems of connectivity. But now we can open up our landscapes for other species other than just the human. So we'll just quickly look at three of these. The first is the Y2Y. That's an extraordinary project that's been going on since the 1990s to connect over 2,000 miles of territory from northern, up in Canada, right down into the United States. And, so this is largely alpine territory, but there's a lot of land use conflict and bottlenecks through this zone. But this is really important work in the sense that when you open up a bandwidth of territory, or when you reconnect a bandwidth of territory like this, you're enabling species to move safely and to adjust to the changes of climate change. And everything's on the move. Humans are on the move. We're getting the message loud and clear that we've got to move back from the coast. Animals are on the move to different temperature bandwidths. Plants are on the move. Everything is always adjusting. So these connectivity projects are pathways for species to adjust and endure, survive, to adapt to climate change. Here's a fantastic photo of a part of Y2Y, which is, hugely picturesque or sublime. But what's important is the link there across the freeway suggests it's an icon of a different set of values, right? Literally transgressing the stream of fossil fuels heading in the other direction and enabling species to cross over that. And so there is a glimpse of coexistence in images like this. The next project is the Great Green Wall across Africa, which has been going for a long time and started out as the sort of the heavy hand of global government, and will pour a lot of money into poor Africa. And it's a bit, the old sensibility of the World Bank. We just pump enough money in and get the mega projects going, things will be all right. Well, of course, they were not all right and will not be all right. And even if it's a project of planting trees, it's not all right. So the project originally lacked any cultural sensitivity, and it was thought that, if we just plant trees, we'll be able to forestall the inexorable drift of the Sahara Desert southwards. That was the motivation of the project. And it's caught up in a whole lot of geopolitical interests, because what's happening is, as the Sahara pushes south, as that desertification occurs, which is now being accelerated by climate change, a lot of the young people from the 14 nations that constitute that bandwidth across the sub-Saharan Africa, the Sahel landscapes, are migrating. And where are they going? They're pushing up into Europe to look for a better life. So they're leaving their own cultures, leaving their communities, which is not good for those communities. They're getting up into, or in many cases, dying en route, trying to get to Europe, or getting into Europe, where that's raising all sorts of racial tensions. And so we have a climate change as a driver, creating a landscape problem, desertification, creating a cultural problem that creates a political problem. And so all these things are connected. But what's fascinating is the project has evolved and is it's evolved in its sensitivities over time, and it's become a mosaic of micro projects. It's still the Great Green Wall, right, as a mega project right across Africa, which is fantastic and compelling, and billions of dollars have been pumped into it. But the way in which it's being put together is through a mosaic of local projects that are tuned to local culture, local ecosystems, and so on. And so there's some lessons to be learnt in that, and I think it's a fascinating project occurring, I guess, at a planetary scale, right? But it's only as successful as its micro-scale projects, its constituent parts. The third project I want to very briefly mention is the extraordinary work by Conjian Yu and his team at Peking University, where the Chinese government commissioned the team to basically do a land use survey and a proposition, a planning proposal for the future of China. And using McHargian methods, Conjian Yu and his team have been able to determine very clearly where development should and should not occur. And you can just see by glancing at the map that there's large areas of landscape connectivity taking priority. And so it's effectively a design for the future of China in terms of its environmental health and resilience at a landscape, at a national scale. And that's compelling because it suggests a role for government in the future that we certainly don't have here in the United States or elsewhere. But with that, of course, comes the spectre that planning can also be oppressive, even if it's in the interests of biodiversity and landscape health. But nonetheless, it's a fascinating project, and where a landscape architect has been able to lead the research and lead the project to effectively redesign a landscape at a national scale. And this relates, of course, to President Xi's vision of, as he says, transition in China from a GDP civilization to an ecological civilization. It's remarkable that a leader of one of the world's superpowers would say such a thing. Finally, the project that we're working on here with students at Penn is World Park. This is a connectivity project. One major piece of connectivity running in the north-south direction and one running in the east-west direction at a planetary scale. You see the dashed lines here. They demarcate walking tracks. The walking tracks are the catalysts for conjoining these landscapes and attracting investment and attracting people. People can walk these landscapes as tourists. To walk the World Park in the left-hand map from the top of Alaska down to the bottom of South America, Alaska to Patagonia, that would take you 2 years to walk. The one that's coming from, in fact, I've clipped off the edge of the image, but it comes down around the east coast of Australia, up through Central Asia and across to Morocco, would take 3 years. So these are pilgrimage paths, you could say. But the idea is that these landscapes, the way in which we've done it is the pathways, you can just see faintly on this image, the path is, or the trail is demarcated in a red line. it's designed such that it picks up as many of the protected areas as possible. So it's threading the needle, and to try and create a continuous bandwidth of land. The idea is that people would not just walk these landscapes as tourists, but they would stop in the landscapes in between the protected areas, which would be designated as landscapes for restoration. The actual construction here, the idea of the World Park is to attract investment and at an international scale, and restore these landscapes to create contiguous bandwidths of habitat. Here's the one from, this is the north-south route, but I've laid it down graphically. We've presented it in this manner. So it's Alaska on the left and Patagonia down on the right. We're just working through the feasibility study for this project now, insofar as we can. It's a huge project, an interesting idea, and we're asking the question, well, how would you do this? How would it actually happen, right? I mean, in the 19th and 20th century, we had national parks. To think of now transcending nation states and building something that is a world park that forges all of these fragmented protected areas together and crosses national boundaries, and could be a landscape of decarbonisation and forestry and ecological restoration, and involve a workforce of people that work on building this thing. I think there's something in that, and it's something optimistic, and it closes the loop for this lecture and takes us back perhaps to the opening, the opening call from Paul Crutzen, where he says we should now move into a period of planetary stewardship. And so I think landscape architects obviously have a big role to play in that. And it's not just at this big scale, it's at all scales. The work we do is important and meaningful, and more so than ever. So with that, I would like to thank you very much for paying attention to the lecture, and I'll sign off and look forward to meeting you in real space sometime. And thank you very much.